Systems are all set. Engines are standby.
All systems are go.
Roger that. Following takeoff procedures.
Calibrating systems. Initiate. Sergeant Winston, Sergeant Michael, you have 3 days to complete your mission. And remember, you are our last hope in saving humanity. Test those oxygen levels. Bring them back. Stat. Do you copy? Winston. Sergeant Winston.
What? How?
Yes, hello? We can hear you.
Sergeant Michael.
Hello?
Do
Oh my
you
god, what
copy?
happened?
Sergeant Winston. Sergeant Michael, send me a signal. Send me something. How could this have happened? Winston!
It's too late to turn back now. We gotta keep going. We can't just go back now.
Yeah, you're right.
Alright, we just need to hope and pray that Ray fixes on his end.
Michael! What the hell is going on here? Oh no. No. This can't be happening. Not now. Not now. Not now. Not now. How could this have happened? Of all times it had to fail now. How could this have happened? How is this even possible? We had tested this in a vacuum of space, tested this for over hundreds of thousands of kilometers. Not a single thing went wrong. But now, when humanity is on the brink of extinction, now it chooses to fail. How? What could possibly have happened? How? 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 This before. Such a magnificent sight. The planet was on the horizon of a black hole. I don't know why, how communications could have been cut off. They weren't meant for conditions like this. How am I gonna fix this? How am I even supposed to start? Where do I begin? Humanity's done. It's over. We have failed them. I can't give up. I can't give up. Not on you. Not on my family. Not on everyone on earth. Not on humanity. I am the last hope. Our last chance to survive. I'll figure out a way for you, my beautiful princess. Wait. Albert Einstein. Albert Einstein and his special theory of relativity. That just might be the way. Special relativity deals with how speed. No. Special relativity deals with how speed affects mass, time, and space. What is the formula? What is the formula we see this represented by? Albert's famous equation. E is equal to mc squared. Energy is equal to mass times the speed of light squared. What does this mean? I see. As an object approaches infinity, that means it needs an infinite amount of energy. The spectrum, as you move towards infinity, speed-wise, that means you move towards infinity energy consumption-wise. But mass can never reach infinity. Mass can never move the speed of light. So this means that the speed of light has to be the overall speed limit of the universe. Speed of light. What was it again? I remember now. 3 times 10 to the power of 6, not 8. What am I doing? I need to focus. Meters. Second. Come on, how is this gonna help it? How is this gonna help me? I see. The special theory of relativity states an object in motion experiences time much slower than a stationary object. So what does this mean for me? Oh my God. If they're in the midst of a black hole, and a black hole is moving at such great speeds, it creates such an immense gravitational field. That must mean they must be experiencing time at a much slower rate comparative to me in my spaceship. Stationary relative to them. But now I need to figure out just how fast is time? What is the difference in time for both me and them? Now I've established that time is moving at a slower rate comparative to them and me on my spaceship. This is because they're in the midst of a black hole that is moving with such immense speeds. It creates such a dense and strong gravitational pull. This means that it has great mass, great speeds, and thus special relativity is able to be applied to this equation. What else can we derive from this? Come on. Oh, I remember now. Special relativity also states that an object, if you have an object A and you have an object B, and I look at it from a third person's perspective, so object C, it states that if I were to ask the person in object A, as he's in motion, hey, how long is your spaceship? How long is the vehicle you're traveling by? He's going to give me the true length. Oh, my spelling is so bad, but I can't focus on that right now. He's gonna be me chewing. However, the person who is watching as A moves at a certain speed, 100,000 kilometers per second, for example, he's gonna say that the length of the spaceship that object A is in come on, is shorter than it actually is. And why is this? That's because special relativity also says that speed of light is shorter looked at from a stationary perspective. Now that I have the basics of special relativity developed by Albert Einstein in 1905, what can I use from this to help get communications back on? Come on, come on, come on, come on. I see now. So this means it's 3 times 10 over 6. I need to figure out just how this time dilated by how much. Oh, I see. Carry the 2, square it, get Lorentzo's factor. You have gamma factor for length contraction, for time contraction, for the speed of light 3 times 10 to the power of 6. That would mean that for every minute they spend on that planet, oh my gosh, every minute they spend on that planet is equated to 7.3 years in my time. I have to get back with them. I have to get on that planet.